So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 200 and in this video we continue with our exercise. In our last video we talked about the login system, and in this video we will talk about the task 2, which is how we to create a linked list and then add some functionality to this list, and then our end goal is to print out this menu here. But this topic linked list is actually a very big topic because there are many things to discuss. So I will only cover in this video what a linked list is. So we will just talk about this, and in the other videos we will talk about these functionalities, because these functionalities which you can see here, there are different variations and how you can implement this and which you can choose. We will have to discuss about this as well, and then about the implementation. And yeah, so in short, in this video, we will just create a single linked list, which I already showed you here in Wikipedia. You can see a linked list, what a linked list is. We can read it here. And then here down, we have different kind of linked list. Actually, this is a single one here, the first one. Then we have here a double, and then multi, circular, and so on. But in this video, we are concentrating only on this one linked list, and we want to create this one linked list in C++, but we will not use this code here below. And the reason for that is this code here is already a little bit too advanced because it is a function. I want not a function at start. At start, we want just understand what is a linked list. After we understand what is a linked list, then we will add the functions to this linked list. That's a very important step. And yeah, that's our goal for this video. But there is one more thing to note here. A linked list will work where we need pointers for linked list. So before we start with this linked list here, to translate it to our C++ code, we repeat pointers very fast. We know already pointers, right? Let's make an example, pointer example, very fast. A variable. How I make this? First of all, I need a type, right? Okay, int. Then I need the this asterisk sign because I want to declare a pointer, right? Okay, so far so good. What I need then? I need then the pointer variable. Okay, let's call it pointer to, I don't know, pointer to anything. Pointer to, let's call it pointer to. All right, and then what I need then? And a pointer need then an address of another type, right? We know this. And how we assign this? Yes, there is this assignment operator and then this address operator. But the problem is here at this point, I have not another type. So before I can use this one, I have to wait, and instead we can assign it to a null pointer, null pointer 0. And null PTR is the thing which we should use. We know this. This is the new version, but null is also possible. Okay, so far I hope you know this is a pointer. And now we need to create an object, because a pointer is pointing to an object, which means it will use the object to manipulate, right? So let's visualize this pointer, and I have here a paint. Let's visualize this. So this pointer which I created here, let's write it here, pointer to. This is the pointer which I just created. And this pointer needs to point something. Let's point to something then. And what I'm pointing is here. I point to something, but like you can see here, right now I point to nothing, to the null pointer. So this is a special place which is nothing, but I need an object. So we have to create an object, and we know, yeah, when we need an object, then let's create one. And important is, when I create an object, and I want to use this pointer, what is the condition that I can use this pointer? Yes, it is this type here, because the type must match. So this pointer, oops, points to an integer type. So I need an integer object. So what is that? For example, int my telephone number. Number is all time integer, and a variable, my value, and I can now use this pointer to point to my telephone number, and then this pointer can use this telephone number. I hope this one is so far clear. Let's make this visual a little bit. So I have created this pointer. Now I create this telephone number, my telephone number, and this telephone number has the value. Let's make the value here whatever, 53. Let's say 53. Just let's make it a little bit short. So, and now this pointer is pointing to my telephone number, but right now this pointer is not pointing to my telephone number. I have to assign it. Now I have created this object, right? My telephone number. And now I have used the pointer to point to my telephone number, because right now it was here in null pointer. Let's say null PTR. This is a special place, PTR. Let's make this one here. And now I must say, okay, I don't want a pointer. You should point now to this telephone number. And what we do in C++ is just replace this pointer here with this address of operator, right? I say, okay, take the address of this telephone number, okay, address of operator, my telephone number, and what we did is we we destroyed this one and said, okay, this pointer is pointing now to this telephone number. And what is the point to make this? Now I can change with the pointer this value here, right? Now I can also use all the things what is here in the storage, right? We know that this one is a storage, and when the pointer points to this place, he can also manipulate the storage now. For example, I can say, okay, let's assign this telephone number 53. It's definitely not a telephone number. It's too short. Let's make it longer. Let's make it pointer to pointer 2. I use this one and make it a longer, but you can see this one is not working because this one is not a normal variable. This would work with my normal variable. A pointer needs one more thing. What was it? Yes, it was this deferencing operator, which is also an asterisk. And this is very important that you distinguish this one. This one is a declaration. This one is meaning I want the value of the pointed address, which means I want this pointer points here, and I want now the value of this address from here. All right, and that is this 53. And here I make this assignment operator, and I assign it a new value here. So you can see I assign this new value, which means right now I'm changing this value of 534. Now I change it with here to 3232, and now this value, this my telephone number here on top, and the pointer have the value here because they have the same storage, right? He uses this my telephone number here. This one here is using this storage, and this pointer here is pointing to this address here and using this storage as well. So both are using this one, which means at this point both have the value this and this. I hope this is so far clear. And this is that what you should already know about pointer and how we can test this if this is true. Of course, we can print this out like all time. And how we print this out? We use the deferencing operator. And let's print both out. So I print this one out, and I print the other one as well out, which is my telephone number. And what we expect is that this both numbers should be the new number here, right? Because I changed it with this pointer. And yeah, that looks very good. And I hope all that what I made here is clear. All right, because this is a pointer and this diagram is very bad, but I hope it's still clear. And this pointer we need for linked list. That's why I made this fast recap so that we know, okay, so a pointer works. All right, that was a little recap, but I hope you already know a pointer at this point. So with that said, we continue. to the next step. The next step is, let's open up this one here. It says we are creating this linked list, and when I go back to this page here, and what I want to do is I want to describe this picture now in C++. All right, so we have this picture here. We are converting this to C++. And let's get started. And again, because pointers are a little bit, a little bit confusing, that's why I try to make again a little bit drawings, and I hope you can follow it. But yeah, I will use this drawing here, and I try to explain with that one. All right, let's see if this is working. So our goal is this picture, what we have, this is a linked list, to convert here to C++. First of all, before we can go here, we have to read this little text here in this box, because it is describing what a linked list, or at least what this one node is. It says here, a singly linked list. This is this one here, by the way. This is just with a single linked list, whose nodes contain two fields. So whose nodes, we will see what a node is. This one is one node, and two fields. This is one field and the second field. Okay, an integer value, in this case it's an integer, and a link to the next node, a link. And you can see this is a link to the next node. It's just arrow here. And this one here, we convert now to C++, this text version here, right? This is our job. And how we make this, first of all, we have to understand this word node. This word node comes in programming in many different places, has sometimes different meanings, but in general, it is just a class or a struct. And why it is a class or a struct? Because it is just a container. And we have to understand this a little bit more in detail. And important is, just think about it, a node is just a class or a struct. And to visualize this a little bit more, let's start and try to understand this. First of all, we have to create a node, right? So let me go here, some colors. I take this here, and let's watch this picture here first. So we have here at the start this box here. This is a box, right? And this box here got the number 12 and this linker. We read this here before, and this box here, what I pictured, is called a node. All right, this box is a node. Let's write here node. Okay, we have here a node, and this node is a box. This is this box here, this here. And I said a node in C++ is just a class or a struct. So is this true? We have to think about this. So this one is just, let's write a class or struct. It can be also a union or anything else, but in this case, most times struct and class. Struct. Okay. And then it says here, this node here has two fields. And yes, a class or struct, I can put in as many fields as I want, right? Fields means here just data which you want put in. But this is a single linked list, so it means you have just one field here and a linker, no more. Okay, I have two parts. This class had two parts. Okay, not this one here. This class or this struct has two parts in this node. One is the data which I want to use. In this case, it's just a number, but must be not number. You can also make a linked list with names, right? And instead, then would we hear the first name, I don't know, another name. But in this demonstration here are just numbers. So I will make here a field for a number, and then here a linker. And this linker is a pointer, by the way. Why is this a pointer, this linker? That's very important that you understand this in C++. This linker is a pointer because, like I showed before, a pointer can point to another what? Another class. And this box here is a node. It is called a node, but a node is just a class. So this one is just a class, right? Class. And this pointer here is just pointing to another class, right? So this linker is in C++ just a pointer. So with that said, we can try to create this here in C++. How we make this? So we know, okay, I need just a class which is a node. So we can call this, let's do this in C++. We need just a box normally. It must be not called node. They call it all time a node. We can call it whatever we want normally, but let's follow their rules. So let's call it class in node. And now I created a very super simple class. This is a very basic class with nothing in it, but it says here we need two fields, right? We have here these two places, and the one must be a number place and the other one must be a linker place, which means in our case a pointer. And in C++, what is this number? In C++, we can choose different kind of numbers actually, because we have integer, we have, I don't know, float and double and so on. In this case, let's say, okay, because I want just to put this image in C++, you can see I just simulate this image more or less, or I create this image here in C++. So I see I have here full numbers. I use an integer, for example. Okay, I call this integer, int variable, and let's call it just number data or something, number data. And I initialize this one with 0 because I can initialize this. You have not to initialize this one, but I all time initialize any variables to anything, so there is no surprises. That's all time a good practice, I think. And then what you can do next is, that was the first field, right? That was this place, and now we have to make this place, which is our linker. Let's do this too. Very easy. And that, like I said, this arrow here is a pointer. All right. Then we create a pointer, and we have just repeated a pointer. What we need to create a pointer, right? This one is just a pointer in a class. So first of all, a pointer needs a type. What is this pointer's type here? So you can see this linker here is pointing from this box here to this box here, and this box here are the same box, which means this is the same thing what we created, the same class. All right, and this box is also the same class here. Okay, these are the same, which means when I created this node class, I know that my pointer in this one is pointing to another node class. All right, in this case it will be an object here. Later we will see what an object is and what a class is more in detail, but you understand it, right? Here I need a pointer to another node because this one is the same like me. And okay, then I write here node. Again, we create just a pointer. We need the asterisk, we need the pointer name, which is, let's call it pointer to node or something like that. And then we need, again, like before, when we create a pointer, we need the address of the other class. But at this point, I don't know it anyway. And here, it's also not an object because I'm not here. I'm here, which is the class. And these two things here are two different parts. What is the difference about this here and this here? Can you see it? The difference is this one is creating this class here, this is this one, and this one is already using the class as an object. So we will create here an object here. I demonstrate this in a moment, but let's continue with this pointer here. So I need this pointer here. So to what, at this point, when I create this pointer, I don't know where it is pointing, right? This is this part here. I create here a pointer, but at this point, I don't know where this pointer is pointing. On what we do then, we are writing a null pointer because this one will be set later when we use it. Right now I don't use it. I can just write a null pointer. And this one, what you see here, is the first part of creating a linked list. This is this node, and this one is just a class which do nothing right now. This one we created now. It has just this, yes, we have just created this node here. It's right here, node. This is just this box. It has here a number, which we can fill. It has here a linker, which we can fill. But right now, this is just this class here. And we learned to use a class, we have to create an object, right? So how we create from here an object? Very simple. We can just say, okay, I want to use this class. All right, I use this class. And I give this class a special name. For example, my first node, something like that. So this is my first node, and then I fill now in this class this values here. This 12, I will put here 12, and I will fill here also this linker to the next one. So let's try to create this object now. This one was our class. This one is the object which is using this class. And how we do this in C++? Very easy. We have created a class, and now I create an object. And actually I can just follow this one. It says my first node, okay? And when I want to use, what does it mean, use the class here? It means just you take it as a type, right? We write it here in front, node. And then I say, okay, here, my first node, let's create it. My first node, and that's it. And so easy, but there is something wrong, right? When I compare this one to this one, here I have a number 12, and here I have a linker, and this node, what I created here, right, has nothing. It has just created an object with the default values here. Just the only thing what I created here is the object name, and I have still the default values here. We have to change this, right? And yeah, we know how to change values in a class by now. We just use the class name and then the access specifier, and then we change here the values. Let's do this. So because my first node, then I use the access specifier, which is the dot, we know this. So, but here I have a problem. Hey, it is showing nothing. I can select nothing. Why that? We go back to the class and see, the default the default access specifier for a class is private. That's why we have to write here public, so that these values get public. If you are using a struct here, then you don't need this public, because by default it is public, but you can rewrite it anyway, so to be sure that you see it. Okay, with that said, now I change this class to public. Now I go here, dot, and I have now access to this both values. And now my object, which I created here, needs now the number 12. And here I'm saying, okay, here's my object, and my object, go in my object, use the access specifier, and assign it the number 12. But first of all, to what? To this number data. All right, let's go to number data, assign it the number 12, and that's it. We have here the first part. Let's do this with the pointer too. So how we do this? Again, I go to my first node, I use the access specifier, and here I use the pointer, and this one is a pointer, but we have here a problem. What is the problem? By default, it's null ptr. So right now, this one is null ptr, is pointing to nowhere. But here I want point normally to the next node, right? So because this one point to the next class, which is just another node. So with other words, I have to create first here a new node, right? Another. And this one needs also another name. So this was my first node. Now I say my second node. Second node. So I have to create this one first, right? And the problem is, at this point you can see it is not created. And which means right now I can't assign. And what we do when we can't assign something, we set it back to null ptr. All right. And then to assign this value here, we have to create first this node. So let's create this second object, which is this one here. I want create. And how we create this one, exactly like we created this one. We use again the class. We create this object. We assign the values which we want in. And you see, this is a repetition, right? We repeat exactly the steps from here. And let's do it for one time so that we can assign this. All right, so what I do is, again, I create the node because this box here is exactly the same class here. And I call this my second node. And by the way, why I'm using here nothing else in parentheses, you notice? Yeah, it's because I'm using the default constructor. You can see this class is a very simple class. I use here the default constructor. So just keep this in mind. If you can even create a constructor, and then you don't have to do this one, because if you create a constructor, you can make an auto assignment by creating this variable. How we make this? Should we make this? Yes, let's make this. But we will probably not use it. How we create a default constructor? Or let's say a constructor just with the class name in parentheses, and then that what we want initialize, probably this one here on top. Let's say here int number data param that I want initialize, and then I use also instantly the initializer here, and then I say okay, this number data here, number data, that is that what I want initialize with this one here. We learned this already. This is number data param, and I think this kind of stuff, you know it, right? So this one here is not a default constructor because I have not assigned a default value, and you can see this makes problem. But we learned also we can make here a default constructor just by assigning it here a default value, for example 0, but the default value should stay the same. But what is the benefit of doing this one here? The benefit is now I can create here a second node and assign directly the value while I'm creating it, so I don't have to use a second line here, which is nice, because that's why I have this constructor, this initializer here. It's initializing all the values by creation this object here. So I can say, okay, my second node should be 99. Okay, that was not a big advantage, but it is. So now I have created this one, but still this the pointer I still can't initialize, which means I can keep here is at a null pointer. But let's make this one. Let's write this one out. My second node dot pointer to, and here we have the same problem like before. Now I created this one here. Now I created here this pointer, but this pointer needs to wait till I create this class here. So the same problem like here, but what is the difference now? We can go back because now I created this one here. I can go back to this step and can assign this pointer to this node. This is exactly that, because now we can assign this one here. All right, let's do this. And what I have to do, again, what is that? This is a pointer, and a pointer needs just the address of what? Of the next class, which is pointing. And when I hover my mouse over this pointer, you can see the class which I have to use is a node, and the class which I created is a node. So perfect. And how I make this? We use what? The address operator. We repeated this at the start with this pointer, and I need the address of this one here. All right, my second node. And we created now the first object, the second object, and now we have to create this one. And you can see I do the same thing again. I just copy this one because I'm doing the same thing again for the third node as well. And that's why I can copy here and change a little bit names. Here I call it my third node, for example, third node, because it's my third node. And then I copy this object, I change this one here, and let's paste this one here as well, and change the value, right? So here's 37. Okay, I initialize it because now I have my constructor here, and then this is shorter. This is the long way. This is the short way, because using of constructor, you can see now why a constructor is sometimes nice. We have not to type so much. And then we have still a problem, because now I created this one. I have to go one step back, assign this one to this node. Let's do this. We know this now. Assignment to my third node. And yeah, we are good to go. So I created now my third node here. My third node. You see that was just a copy paste almost. And we created this one. And now we are at the point where we have a problem. How to create this last part here. And this one. So this last part, actually, we can, if we want, not create at all. We can just keep this null there, because we see this is a linker, and this linker is linking nothing. Here is no value. Here is no anything what we need. But we can also link it to another node if we want, just to a default node. And the reason for that is later when we make a loop, that we can loop these other nodes very easy, but there are different variations. For this purpose, we make just a special last node, which is just a default node, which has just default settings here with no. So this cross here means just no settings at all, which means default settings. We call this default settings here. Default. And default will be not used, and let's not used later. And that is very important that I write not used later. And why that? Because if I create something, another node, and the default node has still data 0, data 0 means this one would be go here. This one would create something like this one, right? 0, and then here this one with null ptr, right? And this one is not the same list here. So we have to say later, don't use the last node here, just use all this one. And that's why we call this last node a special node. And let's do this. How we make this, like all time, we just copy this one. And because I'm not using this one anyway, so let's copy this one. And here I said I use the default values, which means this this constructor here. I don't need a constructor, just the default values, which is that. So I use them. That's it. And of course, a special name for them. My special last node. Special last node. And I have created it. And of course, we just need to go one step back and link this again. Here we have linked the first one, we linked the second one, and now we link the third one as well. Okay, let's link it from here. We know we just link to this last special last node, and we call it again with a ampersand, my special last node, and that's it. So, and this is actually all about a linked list. If you understand this one, then you understand how to create a linked list. The problem here is when we watch, okay, we have created a linked list. We have used the pointers to link them together, right? The pointers are more a linker here, this link part here, this. And the question is now, okay, how we use that linked list. And to use it, actually, we have to dive into the function section. That is when I go up here. This was the first part. We understand how a linked list works anyhow. And now we have to say, okay, how can I print a linked list out? Okay, I think I have to add here one more functionality actually. Let's make it this way, and let's say delayed print linked list. I think I will start with this here, print linked list. because we have to print this out on the screen, right? Anyhow, and this one we will start in the next video. We start with this option because this one is the easiest, and then we will go to the other functionalities. I hope you understand this linked list. Anyhow, important is that you understand how to use pointers. This linked list is working with these pointers, and what is irritating sometimes is that this pointer inside a class is pointing to another class, and then you are using again the pointer inside a class. Try to understand how to use this pointer, because this pointer is here a linker, because when we go to the next part here, to this print list, we will even create one more pointer, which is a loop pointer, which means in the next video we are creating something like that. This is a pointer, a class link pointer, and next video we create a loop pointer, a special loop pointer. And this loop pointer, like it said, it's just a loop pointer. It points here, and then it will go here, here, and while it goes here, 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 it will print out all the values which we want. And that one we will implement in the next video. But I hope you understand this so far with my strange explanation. But don't worry if you don't understand anything. Like I said, this linked list is very, very, very well documented in online. It's there are millions of different solutions. Some are more complex, some are easy. I hope you tried your own version first before you researched it, but if you don't succeed it, no worry, try to understand the versions on the internet. And the good part is the versions on the internet, they use most time really the keywords which we already covered. The only list which you probably will not understand is the library list in C++, because they used already templates, and you should avoid at start, but later we will understand them as well. So with that said, I'm finished for this part, which was just understanding what a single linked list is. But we still understand it not. So what we understand is how to use it, how to print this out, and all this kind of stuff. You can see there are many, many functionalities which we have to cover. All right. If you have any questions, any suggestions, like all time, write it in a comment. And with that said, see you in the next video. Bye, good luck, and like all time, have fun and never give up.